that time zone, good evening. My name is Kerim Satirli. Super excited to have you all here. And we're going to be talking about securing workflows with HCP Vault and Packer, and of course, a little Terraform. So quick intro. I'm a senior developer advocate at HashiCorp, where I focus on the infrastructure line of products. So that's primarily Terraform, Packer, and Vagrant. But of course, proper workflows require oftentimes more than those three tools. So today we'll be mainly talking about Vault and how we can use that. So I want to start out by talking about something that we as HashiCorp think is important. Cloud infrastructure automation, of course, huge buzzword. It looks great on your resume. Ultimately, what do we mean by that? For us, we're looking at consistent workflows. Consistency in the sense that if I deploy this today or 6 months from now, I want it to work the same way. I need to be able to deploy software, sometimes hardware, provision it. I want to make sure I have access to credentials and secrets management. I want to be able to run networking between those parts, be that a VPC if you're in the Amazon space, or maybe a direct connect, or service meshing, many other ways of making that happen. And of course, ultimately, run applications. Lots to think about. We have products for all of that, but this isn't about that. This is specifically about provisioning and securing. And let's dive right into that. I'm the kind of person that doesn't love doing a lot of slides, but some concepts bear visual explanation before we jump into the code. And we'll definitely do that right after. So let's start out with a tale. If you've been using Terraform for a little while, you might know the concept of workspaces. It loosely maps to environments, but doesn't have to be used that way. I like to think of it as a gated community in the sense that you can do things in there without affecting things on the outside, but you're able to connect to the outside in useful ways. In our case, we're going to be using Terraform Cloud for today's walkthrough, because that makes it a lot easier and it makes it possible for me to collaborate with other people. And the reason that is important is ultimately we're codifying our infrastructure. And when you write code, eventually you're going to make mistakes. Now, of course, I know all of you that join don't have that problem. I certainly do. So I like sending out my code for review to others and making sure it's as clean as possible and as predictable as possible. The reason for that is real simple. If I write proper infrastructure code today, then hopefully 6 months down the road, pending a change in the cloud provider's API, everything will still work the same way. Comes back to that consistency. So let's start out by deploying a workspace in Terraform Cloud. And in our case, what we're going to be using is a Terraform provider for Terraform Cloud to deploy more Terraform Cloud workspaces. I know we all would love to see an Inception GIF right now and a nice meme on that. I'm sorry I couldn't find one that we could approve through corporate communications, but we're definitely thinking of it this way. When you use Terraform, eventually you're going to use Terraform for more and more things. Terraform right now has 2,100 providers. We cover all the major clouds. We have a large community building providers and expanding that ecosystem. So you truly have pretty much everything you can imagine. It doesn't matter if it's AWS or GCP, Kubernetes or Datadog. Usually, if you can think of the service, then somebody built a provider for it, including, if you're wondering, a provider for Domino's Pizza if you're in the US. So there's options. Though the concept of Terraform Destroy with a pizza resource is a little bit tricky. So we'll not dive into that too much. So we'll start out back in Terraform Cloud, a single workspace to manage our other workspaces. And the first one we'll create is a Vault deployment workspace. Goal here, we want to deploy an HCP Vault cluster or multiple. So that means we also need to have some networking for that and some other things associated with it. And then once we've deployed that workspace, we'll deploy another one, Vault config. And you might be wondering, why are those separate? We'll get into that in a second. If you're not wondering about this, probably you are at this point. So we'll configure a Vault cluster. In our case, it's HCP, but the code that I'll share with you, you can use for any Vault cluster. And we'll configure it for use with AWS. Then next up, we're going to be creating a repository to create some Packer templates and render them into EC2 instances, or sorry, build them into EC2 instances. Though thinking of it as rendering is an interesting concept. And ultimately, we'll create another Terraform Cloud workspace to use information from HCP Packer and then use that to deploy EC2 instances. Now, we talked a little bit about this before, 2 or 3 minutes ago, on why these are separate workspaces. And if you look at your screen, you're seeing 4 workspaces plus the Packer template in the lower left corner. The split between these workspaces provides us with isolation. And that's the gated community concept that we talked about in the beginning. So on the left side, I have a workspace that creates my workspaces. This is something that I want to make sure as few people as possible can actually interfere with, as few people as possible have access to. Because ultimately, I want my workspaces to be set up in a very specific way. All of them should have a specific version constraint. They should have specific variable access and other things that we can define as code. And the reason we're doing this as code is, of course, it's easy to manually configure a single workspace. It's easy to do it with 2. Once you start doing this for 100 workspaces, things get a little bit harder. And it's usually easier to just use code to configure those workspaces. Similarly, when we deploy an HCP Vault cluster or any software, we want to have the deployment separate from the configuration of it. And the reason for that is that we might be able to exchange the cluster, the underlying cluster resource, be that Vault, be it Consul, or any other service, while keeping the config around. Usually, your cluster deployments will not change as frequently as the configuration of those clusters. So we're separating those in logical ways, making it easier for engineers that join us along the road to make changes without affecting everything. If you look at it on a research level kind of scheme, Vault deployment, for example, that workspace does networking. It establishes a VPC connection, apologies, between the HashiCorp virtual network and your virtual network. And that's something you want to make sure makes sense. So there's a little bit of network knowledge required. Of course, we'll provide you with ready-to-go code that you can copy and paste. But ultimately, it comes down to understanding your CIDR ranges, making sure you have no overlaps, and making sure you have a system in place that allows not just use right now, but also use down the road when you grow. On the Vault config side, we might be having multiple clusters that can use the same configuration. Maybe you have multiple AWS accounts. Maybe you have some in the EU, some in the US. Maybe you also work with the government, so you have access to GovCloud. It's nice to split these things out. We're talking about this here in terms of Terraform Cloud workspaces, but a lot of this ultimately becomes a module. And it's a little extra abstraction that makes it easier for you to maintain these things and ensure consistency down the road. So before we jump into the UI, just gonna give you a quick preview of what you're gonna see. We're gonna be using Terraform Cloud to deploy our workspaces. So you can see a couple of them here. We've got everything obviously defined as code, so you can run the same exact demo at home, hopefully without your camera glitching out. And then once you're ready for it, head on over to HCP Cloud and try out the services there. And so we'll get to the useful links in a second. Let me quickly switch over to sharing my screen. And the first thing we want to do, and let's make this a little bit bigger, and do let us know in the chat if you're able to see everything and if it's large enough, and if not, we'll make sure it's larger. So we've got a code repository for you. We've got the links coming up later. We'll also send them out with the recording. And yes, in case it wasn't clear, we are recording this so you can enjoy the content of this webinar at a later stage, still without camera though. So if you check out this repository, the first thing you'll notice, a lot of dot files. What I've tried to do here for you is create a repository that mimics the way we would deploy this. It aligns with our best practices. And of course, we throw in a couple of useful GitHub actions, linting tools, and everything that makes your Terraform workflow easier. A couple of things that I want to point out here. Huge fan of tf-lint, which allows me to go a little bit further in ensuring code quality. It helps me find variables that I defined but don't actually use. Same for data sources. And of course, once I'm done writing my code, Terraform docs to generate my documentation. Goal of all of this is, as many of you, I'm a very lazy engineer. If I can save myself the time of having to manually update my documentation, I will absolutely do that. And if you know the XKCD comic, yes, I will definitely spend more time on automating something than it might take in the short run, because in the long run, it will work out. So with that, let's hop on over to the code. Actually, let's hop on over to HVN. And while I quickly sign in again, we'll get right to it. And if you know corporate software, then you know that the way this works is you will sign in and always be signed out at the exact wrong moment. So if you've never seen it, this is the HashiCorp Cloud Platform. We're on the dashboard. So currently we have Consul, Packer, and Vault, and Terraform is a standalone service. And from an engineering perspective, here's what I love about this. I used to run Vault servers and Vault nodes and agents in a previous job. And while it's a lot of fun to get it up and running, it is a complex system. I am very excited about the fact that at this point, I have roughly 10 lines of Terraform code that I can use to get a full server up and running. But the first thing we need to do here is create a virtual network. And so the way this works is currently HCP Vault runs in AWS in a couple of zones around the world. And so we'll establish a peering. And let's grab this one. And you are actually able to see that, apologies, that was a wrong click. We've got a stable connection here. In our case, we're using EU West 1, but you can also run this in EU West 2, EU Central, and a couple of zones in the US and around the world. So on our side, what we have is a connection to a destination VPC. This is on my side. And let me just show you how this looks like. In the console, you get all the right information to make this change. If this is how you want to go about it. If you want to copy and paste it into the AWS CLI, totally works. I would highly advise just using Terraform for it, because it does make it a little bit easier. And in fact, if you click the Manage button on the upper right, we have a command here for you that you can copy and paste and import these resources into Terraform. And ultimately, of course, once your peering is up, you get a couple of route tables allowing you to make things work. So with that, let me allow to hop over to our code a little bit. And we'll start out in the Terraform Cloud workspace. And while we're here, let me briefly log in to this system as well. You'll notice with security software, one of the biggest things that you have is token expiration. That's a good thing. It's a little bit, it can be a little bit annoying when your token expires right before demo, which is the case for me, but it's actually not as bad because ultimately we're making sure nobody else can see our tokens. So at this point, if you're looking at your screen, you should be seeing my editor interface. If this is a little bit too small, drop us a note in the Q&A, drop us a note in the chat, and we'll get the size up. So if you've never seen Terraform before, this might be a little bit too far down the road, but the concept here is that we're using Terraform Cloud to run Terraform code that deploys Terraform Cloud workspaces. And we're using the TFE provider for this, originally named Terraform Enterprise, but Terraform Enterprise, Terraform Cloud, they use the same API, so you can use the same code. So even if you're running this on an air-gapped network, you can still do the same exact thing. So first thing we're doing is defining a workspace here for our Vault deployment. And in the code, I've left comments for you to all the relevant resources, a couple of gotchas. For example, don't use a for each for Terraform Enterprise, or sorry, Terraform Cloud workspaces, because a for each might not do the same thing you want when you delete one of the workspaces. Can be a little bit tricky. I know we're all about DRI, dry, and making sure we don't repeat ourselves, but there are some parts in your code that you might want to consider repeating, such as workspaces. So Vault deployment and Vault config, nicely separated and easy enough. And so if we run these, you just run a plan here. And you'll notice this is live because of the spelling mistakes and everything else involved. And while this runs in the background, I'm actually using Terraform Cloud to run this. I'm using Terraform Cloud 1.2.1, which came out roughly 10 days ago. So huge fan of being on the latest and greatest, especially because of the pre and post conditions that we have in there and some nice changes that you can run. And you'll notice that I've already previously deployed this, so everything here looks good. And if you remember the screenshot, it is an actual live thing. You should see the live update here. We use a Terraform Cloud organization called a demo organization. Of course, if you play with this code, if you try things out, make sure you change the organization identifier and try out your own code base on your own organization. So really simple, defining these workspaces here. Let's do something a little more interesting. So first thing we're doing in our outputs, and this is something I like to tell people about because it doesn't happen as often as you should be doing it, I think. Terraform outputs are a great way to get stuff back from Terraform and get it back in a way that works for you. In my case here, I'm just printing out the workspace URLs. which makes it very easy in my editor to just click them and go to the right location right away. All right, Terraform Cloud with Terraform. It's cool. It's not everything. So let's do something that's a little more fun. Let's create ourselves a Vault cluster. And the place where we would do this is in the Vault deployment code base. And to do that, I want to make sure this is easily connected to all of my data. So I'm going to use the default VPC, which you should have in each VPC in each region. And if that's not the case, because you might have thrown it away, I've definitely made myself guilty of that. The easiest way to get that back is to just send a ticket to Amazon and ask them to reinstate it. The default VPC is usually beneficial because most of your compute, most of your other connections route through that. So unless you have a very specific network case where you need other VPCs, the default one usually works. So first thing we're doing is we start out with the AWS VPC data source. We're grabbing the default, and in our case, we're setting state available. And the reason for that is that Amazon has a couple of VPCs that have different kind of networking, such as the wavelength zones, if you're into mobile tech, and those filter down differently. You don't want to have one that's state pending or state disconnected, because ultimately a network connection that is not available is not a connection. So next thing we're doing is setting up our VPC. And as you can see, right now we're setting this to cloud provider AWS. But if you paid attention while we were looking at the VPN setup, VPC, apologies, you may notice that we're also working on getting this up on Azure. This is not currently a public beta, but if you're interested, definitely give us your email address in a follow-up. In the follow-up that we'll send you, we're curating a list, we're randomly selecting people as we go down the road, and maybe you can help us test this. So setting up our HVN fairly easily, 6 lines of code. It's my preferred way of doing networking because somebody else gets to figure this out. And of course, we have some peering. And in this case, I'm also using a resource from the AWS provider to accept the peering connection. Normally, if you've ever accepted one of these, you know that you have to log into both AWS accounts. That can be a little bit tedious. So I like to automate that. And if you're doing this between 2 AWS accounts that you own, what you'll want to do is define an extra provider for the acceptor. So you would say AWS acceptor, for example, as the provider. And this is not going to work because I don't have the extra provider set up. But you would go about it this way, giving it a provider alias, and you can still use the same code base to do this for you. There we go. And we're back to having it the way we expect it to be. Now, with our HCP HVN set up, which is usually the easy part, let's go ahead and deploy ourselves a Vault cluster. And in my case, I like calling my resources main. I do a lot of this stuff with modules, so I'm usually used to making sure everything is called main anyway, because ultimately that's how your modules call it, and the special naming comes from how the module is called. And I see Sam asked us a great question. So if we set up Vault via Terraform Cloud, does it mean this cloud org can't use this Vault for its own secrets, as this is a circular dependency? So this is actually a great question, Sam. So if you have a Terraform Cloud workspace that sets up HCP Vault, are you creating a circular dependency? Yes and no. Yes, if you have a single workspace that sets up the Terraform workspace and then the Vault server in there. Of course, you can use depends on to mess with the graph that defines in Terraform what happens when, but that's not really optimal. Our recommended way is to split it out into several workspaces. So the place that provisions Vault shouldn't need access to Vault, and you should ingest those secrets in a different way. Usually at this point, if you're just deploying a Vault cluster, the only thing you need access to are your AWS credentials, and that should be easy enough to provide at one point. And because they're going to be slightly further reaching, you're going to need access to VPC, you're going to need access to be able to accept the connection. Having a very, very limited account for that with a super strict IAM policy is how we like to suggest that you deploy it. Now, it's of course not as easy as just popping in root credentials that AWS gives you on the first try, but it does make for a more secure workflow. So in our case, we've set up our Vault cluster. You'll notice that I've defined a few variables here, mainly for cluster ID and which versions I'm using. And so let's have a quick look at those. You'll also notice some validations in here. I'm in Europe, so I like to make sure my code mostly runs in zones here because I hate network latency. We've also got some other setups here for the CIDR blocks and everything else. Of course, keep in mind that these are values that we have that work for us. Your network might require something else. As with all of these things, consult with your network team if you have it, or otherwise Stack Overflow and figure out which CIDR range you should be using. Next up, we've got a couple of IDs for the cluster and the HVN. I specify these as separate ones because of the way I do my setup, but there's nothing against reusing the HCP HVN ID for every place where you want to have this exact string. Next up, I'm defining a public cluster endpoint, and that has a very specific reason, which is that I do not consider blocking the network access as the best line of defense. You can mess with IPs, and if that's the layer of protection I need, then I need to probably look at my authorization and authentication strategy a little bit. Also, I use the same Vault cluster to run GitHub actions and provide those with credentials. So ultimately, I need access to my cluster. Now, what a public endpoint means is just that Vault is accessible on the public internet. It does not mean that there's no login to Vault, of course. Otherwise, it wouldn't be a very good security product. Next up, I'm defining the tier of my Vault cluster. I like to use the dev cluster because it allows me to get all the stuff done. I use it for storing secrets, such as license keys, tools like Portainer or anything else that has a license key. I like to think of it as a secure key value storage in that sense. The reason I have it in Vault is when your license expires, if you're using Vault with the KB backend, you have versioning in there, so you can just pop in a new license. Nothing ever needs to change in your Terraform code. And on the next deployment, you'll have the right license. And then, of course, GitHub actions that call in. But we have a lot of other sizes available, depending on your usage, depending on your requirements. You know, do you need backups? What kind of support do you need? Do you need up to the minute snapshots, or maybe, you know, at a different interval? We have different sizes for that available. And then, most important one, we want to specify the version to start our server with, our cluster. In my case, I'm using 1.10, but depending on the organization you work for, you might have different requirements. Maybe you can't be on 1.10.3. Maybe you need to be on 1.9 still, because you have a very specific requirement that changed in 1.10. Software is ever evolving. And of course, ultimately, we want our code to be consistent. And the largest part of that is really version pinning. We treat oftentimes we treat infrastructure as code as different than normal code. Normal code being, think of any Node project, React, anything that uses NPM or gem files. We've always specified versions. And it helped us make sure that when somebody releases a new downstream dependency, upstream dependency actually, nothing would break in our code because we're still stuck on 1.2.3 or whatever version you had. Yet with infrastructure as code, this is not as common. So what you really want to do is lock down the versions that you know work. And that gives you consistency down the road. It makes it easier for everyone in your team to understand what's going on. And ultimately, when you understand what your code does, you're getting buy-in, you're getting people's understanding. I'm not currently on call, which I'm very grateful for, but I know a lot of teams I've been in, when we were on call, the first thing was always to figure out versions. And ultimately, you get really good at that, but it shouldn't be the question you need to ask. Doesn't make sense. So in our case, let's define a few more variables to make things easier. I'm very much about making operators happy, making sure the things you expect your software to do actually happen. And so in our case, that's what we're doing here. So let me give you some outputs here from Terraform to see what I'm talking about. You'll notice that all these URLs get printed from the code that I have in here, which makes it a lot easier for me to see what my Vault deployment looks like. I can easily head over to the portal. I can consume these in other tools. So for example, if I need to get the public endpoint URL, I could run Terraform output with that value and get it as a string that I can then consume in something like Ansible, or maybe you're running this in GitHub Actions, Jenkins, whatever you have, you can consume it this way and pass the data from Terraform to that system. So we've defined in our Vault deployment, we've got our server up and running. We've also got the cluster admin token resource, and huge call out here. It is in the code, but I'm just gonna say it out loud as well. The Vault cluster admin token resource can be useful, but it also means that you will persist a 60-minute valid token, root token for your HCP Vault cluster in Terraform state. If you're using Terraform Cloud, not a huge deal, because your code is secured and you're allowed to see your token, but it's worth pointing that out. The other thing, this is a Terraform resource. Disabling this resource, so basically commenting it and then running another Terraform apply, will not remove this token from Vault, because Terraform does not do a Vault token revoke call underneath in the provider. And so if you remember when we were in the slide section, we had the Vault deployment workspace and we had a Vault config workspace. And so here's where we're going to have some fun. Ultimately, for me to use stuff from Vault, I need a couple of things in my code base. I need access to a Vault address. So that's usually an environment variable called vault_adder. And I need access to a token. And so in the Vault deployment workspace, we're going to use the Terraform Cloud and Terraform Enterprise provider again to create some more workspaces. And it all trickles down. And those workspaces are the HCP Packer registry and the HCP Vault config. And in those, we're going to be injecting some variables. And the reason we're doing this is really, really simple. I can print out these URLs for you on the screen, but if you have to manually copy them over, then you increase the chance of having an error. You make it harder for yourself to see what's going on. You need to remember doing this. So if I can make this simpler by codifying it for you and defining it as a resource, and in my case, I loop over the workspaces that I have, then that makes my life so much easier. And it makes ultimately everyone's downstream workspace lives easier as well, because they'll have a variable available to them called HCP Vault cluster ID and a token, which we call Vault token. We set it as an int variable. Of course, we treat it as sensitive, which means Terraform will not directly output it to screen. Very important, because ultimately I don't care what the value is. I just need it to be set in a way that it is very easy for me to ensure it is actually right. So the Terraform Cloud workspace creates the Vault deployment workspace and a few others. Vault deployment then fills the downstream workspaces with the right tokens and with the right variables that we need for consumption. And so let's have a quick look at the Vault config workspace. Now, if you remember from the Vault deployment workspace, the thing we're making available is the HCP Vault cluster ID. And where this is useful is if we go into our Vault config workspace, which should pop up on your screen, we're using the HCP Vault cluster data source to retrieve information about my HCP Vault cluster. And so let me run this command real quick and show you what's in this data source, because that's actually where things get a little bit more interesting. So depending on how fast Zoom screens refresh, let me actually show you. So I'm in the Vault config workspace. I'm going to use a Terraform Consul, which is a great way of debugging these things. Think of it as an easy way to manipulate your data and play with it if you copy it the right way. So we're going to use data because this is a data source, followed by HCP Vault cluster, followed by the Terraform resource name, in this case main, and see what's in there. And you'll see we have a JSON object, includes our cloud provider, and of course, when it was created, our HVN ID, also the ID in the UI, which versions we've defined, which Vault namespace and which organizations it's part of. But most importantly, we have region here, and we have our URLs. Now, if you look at your code and you go like, well, but of course, you're going to see 110 here because that's what you define. It is, but this is a different Terraform workspace. So being able to retrieve this information actually makes it a lot easier for me. So to come back to Sammy's question, the reason we're splitting this out is that I'm running Vault config in this workspace, and it makes it easier for me to focus on what I want to configure. Ultimately, I don't care if this is my Vault cluster or Luke's Vault cluster or Sam's Vault cluster. All it matters is that I provide a cluster ID that I have tokens and access to. And with that information, we can then also configure our Vault provider. So the same address that works here will also print out here. And if you're fast enough, you can actually copy and paste that and visit it in your browser. And so I use a lot of this data to inform downstream configuration. In this case, you'll notice that I actually use the region my Vault cluster is deployed in to configure the AWS provider. And the reason I do this is because I may have multiple Vault clusters. I have one in this exact region. So for latency issues, it's a little bit easier for me to just say, I'm going to copy this value over, or sorry, dynamically use it instead of copying it over. Meanwhile, if you have questions, of course, feel free to pop them in the chat or in the Q&A section, and we'll get to them in a second. So next thing I want to show you, since we have configured our Vault provider here, which you can see here, let's configure a couple of different things inside Vault. And we're doing all of this through code. You can do this through the Vault CLI. You could write some curl statements to do it through the Vault API. While that's super cool, and it will definitely get you a lot of internet points, it's usually easier to just do it in a more codified way, because ultimately you can also modularize this and share it with more people. So set yourself up a Vault mount. In this case, we're using the key value secrets engine for version 2, and we'll also set up a Vault secrets backend. Again, in the same region. And then we'll set up an IAM user that we can use to do things with this. In our case, I'm specifying that I can use both EC2 and S3. And to make things a little bit more passable, and because I don't know you all and I don't want to show you my AWS credentials, I'm also limiting my setup here by IP. What I'm doing here is I have hard-coded an IP address that works for me. And I've set it in the Terraform vars file, which works just well. So my home IP, and the reason I have this in here is because normally in Terraform, you could use something like the HCP data source to retrieve your IP from somewhere. But because I'm running this in a Terraform Cloud context, Terraform Cloud actually retrieves its own IP, so this policy would never work for me. And then once I've defined my IAM policy that I'm happy with conditions and the right effects, I can set up a secret backend role that gives me an IAM user or IAM user credentials. And so let me show you first what this does. So let's release the Terraform Consul log and print out some outputs and have some fun here. So Vault address, of course, we're used to. I want to experiment a little bit with Vault. So I'm going to use the Vault environment variables output that I have defined here, which sets up the right values for me. And then the next thing I want to do is read some credentials. And the reason this works right away is because I've already done a Vault login. But if you haven't done that, the way you would go about this initially, because we haven't defined any users yet, is to go into HCP, get an admin token, log in, because we're still in the initial deployment phase, and create your credentials there. And so what I'm doing with this command is basically creating a value that works for me and that is specific to the policy I defined. My value will be valid for 1 hour. It will be bound to my IP, and I can use this to access my S3 and EC2 credentials. Note that in the policy, one thing we're not defining is IAM. So for example, if I want to do anything with IAM, this policy would not allow that, and that's a good thing. We talked about this a little bit before. Sam also asked a question around that in how it makes sense and how it doesn't make sense to set this up. And basically, by limiting our IAM policies to the least amount of things required, like the minimal amount, in our case, some networking and some token vending, we make it a lot stronger for ourselves. Now, of course, the important point here is, let me see, just clear my console real quick. There we go. The policy we've included is wildcard for EC2 and S3. This is not what you should be using unless you truly need the wildcards. But chances are you don't. Make these policies as restrictive as possible. Terraform can handle thousands and hundreds of thousands of resources in a single code base. So if you want to define multiple IAM policy documents, just go ahead and do that. Have very specific policies. Use the policies you already have and build upon those. Usually, the more specific your policy, the better it is. Wildcard is usually not a good thing to have in there. So we've defined our vault tokens and everything, and let me just go ahead and head on over to my browser, copy over some URLs, and also a token or two, because I noticed my token had already expired. And this is how you can tell that this is all live, because our tokens did indeed expire. And that makes things a little more fun. So here we've got our public Vault backend. And you can see the setups that I've done, the KV secrets engine, the AWS engine, and you'll notice the role that we have for consumer. And in here too, I can generate credentials. Not every user will always be using Terraform, and that's totally okay. In this case, I can just do it through the UI, which is sometimes a little more comfortable for people that don't do everything through codification. Imagine you have a team that needs to be in AWS or needs to be inside Kubernetes or any of the other systems that you can use with this, but doesn't actually understand how to do it through the CLI. You can just head to the UI and get those same credentials, and you can copy paste them, bring them back to your code, or just use them straight from here. And then ultimately, we can see what we have associated with that. I'm logged in as an admin, so I also get to edit the role. But of course, if you are the end user of this, the end user who's generating credentials and not just a role, you would not see all of these options. And then through my setups, I can also see a couple of other things. So you'll notice the HCP Vault cluster that I deployed is an enterprise cluster, which means you get all the enterprise features. And sometimes that can be very helpful, especially if you have complex use cases and have specific security requirements that an open source Vault cluster can't fulfill for you. And of course, while we're here, some ACL policies. In this case, I'm allowing the consumer to read secrets as part of the secret backend, in our case, the secrets engine. And you'll notice we have an example secret in here, which we set through Terraform. And the reason I set this through Terraform is that I like to think of it as a smoke test. So I deploy a Vault server, and if everything is correctly configured, I can set a token inside Terraform, knowing full well that this token is now part of my Terraform state, and then retrieve it through the Vault CLI. And the thing that tells me is that one, Terraform was able to successfully authenticate, which is very important for the Vault config workspace. Two, Terraform was able to write this to the secrets backend, which means I've configured that one correctly. And three, if I can retrieve it through the Vault CLI, that means I'm able to authenticate and retrieve my secret from there. And that's all for Vault. So then we've got our secret set up. And for the sake of time, let's jump a little bit further. Quick jump into the Packer code base. Now, our goal is to deploy Packer images, first build them, and then make them available. And so I'm going to be using Ubuntu 2204 LTS, Jammy based. So once again, a data source, because it makes it easier for me to look up things. I specified a filter of what I need. Today, I want to use the most recent. And in terms of owners, I'm going to be using only images that come from the AWS organization owned by Ubuntu. And then some basic Packer setup. You'll notice that we switched from Terraform to Packer, but the code still looks pretty much the same. That's because Packer switched from JSON templates to HCL templates in 1.5. And that makes operator lives a lot easier, if you ask me. Same language, almost the same type of variables. Of course, Packer has a little bit of a different dictionary than Terraform, but there's no more switching in your head. How do I do this? How do I do that? Both of these tools have access to data sources. Both of these tools have access to other statements, variable statements, and it makes it so much easier to define. So basic setup, some run tags, of course, very important. Also some build tags. One of the things that we like to do is make sure when you look at an AMI, you can actually see where it came from. So what's the source ID? What's the source name? What's the source region? Because maybe you generate something inside GovCloud. Your tooling will be different than if you generated it outside. Maybe you need to copy something over. Spoiler, you can't actually. But there's ways to make sure that your data is consistent. And ultimately, and this is where it gets more important and interesting for our team, we're specifying a Packer registry. And here we're also providing a couple of labels, making sure that we have access to the source ID, source name, and we could just run a Packer build. Now, in my case, I don't know if I have the time for that because it takes more than 3 minutes. So imagine that we actually did run Packer build and we were indeed able to build our image. And let me just switch to the HCP registry. You'll see that we have an image called Securing IAC Workflows. And I published the last one 19 hours ago. This will automatically update if the build in the background finishes. But for now, what you can see, we've got our source ID, source name. All of this makes it very easy for me to see what does this image do? Where does it come from? What source region? But also, what were the things that were installed with that? Was it non-approved Python version? Is there a Yum repo, or in this case, an app repo that would not be included by default because back then with the 0528 image, you wouldn't have that. Changes like these are a lot more easy to resolve and understand if you have access to all this information. Also from an engineering perspective, storage is cheap if you can have this information available right from the get-go, especially with dynamic lookups like these, you're making your life easier and you're making your security team's life easier, which to me is always a huge win. So we've got a couple of iterations on this image. Of course, you know how it is. The first build never succeeds fully, or maybe doesn't contain all the things you wanted it to have. So I've got the V4 version, the V4 iteration of this image currently assigned to staging and production, 2 of the channels that I use, and that down the road I can use to deploy with Terraform. And so if we go into Terraform, you'll see that these, what are we talking about, 20 lines of code allow me to retrieve those IDs from HCP Packer and bring them into Terraform and then ultimately deploy an image with that. And where this gets fun is that in Terraform, I no longer need to change my lookup. If you remember in Packer, we definitely had to change the lookup. Or have to change the lookup. It does make things harder if you have constantly changing images, but it also means that you're constantly changing your code. And ultimately in Terraform, the thing I want is I want to define what my policy is and my strategy around this, and then go from that. So in this case, we're defining the consumer iteration and with the right bucket name, of course, all through variables. And then the only thing Terraform needs to worry about is retrieving that ID. And so if I do a Terraform plan in here, let me see if I'm still logged in. Then here we go. So we're going to wait for the plan to start. But at this point, I feel like we've spent an hour together, so I know you trust me. This would just retrieve the latest version that I've assigned to a specific channel. In this case, I'm grabbing the production channel, which has my AMI ID in here. And that just works. And if I log into my Amazon account, which of course also has timed out. So we're just going to have some fun here and look at it in the console, which is more beautiful anyway. We can see that because I threw away the image, we're creating a new instance with the correct AMI ID. You'll see a lot of settings are known after apply because I didn't specify them. I wanted to make this very bare bones. We're seeing our tags. And if we scroll down, we're also seeing a large number of outputs. So redirect to the AMIs in the AWS console, and then some information about my Packer image. Ultimately, the goal of this, of all of this, is to make it easier for you and your team to understand what's really going on, without having to copy and paste things over from left to right, without having to constantly go through everything. And that's pretty much what today was all about.